Module 5, problem number 14. Do women feel differently from men when it comes to tax rates? One question on a survey of randomly selected adults asked, what percent of income do you believe individuals should pay in income tax? Complete parts A through C. So here, let's take a quick look at our data set. Here we have this side's all the tax rates that women believe we should pay, and here are all the tax rate that men believe we should pay. I'm going to go ahead and open this in StatCrunches because I know we're going to be using it. And then I'm going to put that just aside for a minute so we look into what we're doing for Part A. So for Part A, draw side-by-side box plots of tax rates by gender and choose the correct graph below. Now you could really eyeball this, I'm sure, from the data set, but let's go ahead and do it in StatCrunches to compare. The first thing I'm going to do, I know that this column is for our female survey responders. Here we're going to change the column names and just delete out just so it's a little bit more in line with what this is how I prefer to view it, but also more in line with what we've been doing so far in the class. So you see here we now have two columns, one female column, one male column. So to do our box plots, we're going to go to Graph, Box Plot. Just like we've done in previous sections, we're going to select both of those, and we're going to go down here and click on Draw Boxes Horizontally so that we're not looking at vertical box plots. It's a little easier to compare. So here we've got our male and our female. So let's just do a quick little check. First, I'm going to point out, here's an outlier. Let's see if we've got any outliers on our plots here for comparison. I see one right here. So I'm already leaning towards this. Oh, and there's one right there also. So let's see. Let's do this. Again, make it a little easier to compare. So here we've got the males a little bit shifted towards the left. So maybe males do think that we should be paying a lower income tax, and the females are a little bit higher. Here we can see this is right between 10 and 15, and it's closer to, it's a little less than 15. This one, the female, that center line right there, that median right there is above 15. So that means the fact that we have an outlier at the male, the median right there for the female, and the males on this side tells us that we're looking at plot D. Let's check that answer. All right. If anyone has any questions about that, let me know. It's just a simple comparison, though. There was nothing too technical there. Does there appear to be a difference in the income tax rates between genders? So here we have no, because the income tax rate is about the same for males and females. Yes, because the income tax rate for males appears to have a higher median than the income tax rate for females. Well, that's not true, so we can already just get rid of that one because the male median here is lower than the female. No, but the maximum income tax rate for males is higher than the maximum income tax rate for females. Again, that's not true because we're seeing that that is true because we do have that outlier, so I take that back. And then yes, because the income tax rate for females appears to have a higher median than the income tax rate for males. Just looking at it, the difference here, I'm going to say, because that's an outlier, so we wouldn't really consider that as part of our analysis, that could sway our results. I'm going to say yes, because the income tax rate for females does appear to have a higher median than the income tax rate for males. So let's check our answer. Nice work. Again, this is just from looking at the box plot. This is just some initial analysis, and this is a really common practice in just all sorts of statistical analysis, whether it be regression that we're going to talk about in Module 6, or if it's this type of just statistical like hypothesis testing. It's really common to just get a quick look at plots, just to kind of get an idea of what you're looking at before you dig into the details. So Part B, explain why a hypothesis test may be used to test whether the mean tax rates for the two genders differ. Select all that apply. Just before we go any further, I wanted to point out where these requirements are listed. These requirements are listed in section 11.3, Objective 1 on slide 3. And this is also right before it gets into the steps of how to do the hypothesis test. There's just this little section up here that goes through all these different requirements that you have to meet before you can do the hypothesis test. So we're just going to talk. So first we have sample size is obtained independently of the other. This one we can kind of assume. Each sample size is small relative to the size of the population. That's that requirement right here where it talks about how your sample size must be less than or equal to 0.05 your population size, you don't want to have a sample that's like 90% of your population. You might as well just say, okay, that's our population. So that's what the reason for that is. So we're going to say sample size is small relative to the size of its population. Each sample has the same sample size. That is not a requirement. You can have samples of different sizes, and that's fine as long as they meet the requirements on their own. Each sample size is large. That's something that you need to have is big enough. Again, going back over here where we talk about each of the sample sizes must be greater than or equal to 30. That's what that's referring to. And then each sample is a simple random sample. It does need to be random. So those are the 4 that apply. Excellent. All right. Test whether the mean tax rate for females differs, and that's a key word there, differs from that of males at the alpha equals 0.01 level of significance. The fact that they use the term differs and not is greater than or less than tells us that this is a two-tailed hypothesis test. So then we know, just based on what we've been talking, we're looking at the mean, because we're not dealing with a proportion, we're looking at the tax rate. We're looking at the average tax rate, not a proportion. So that's going to be equal to, the males are equal to the females. So the mean of the males is equal to the mean of the females. And here, again, we're looking at that differs. That tells us our alternative is going to be not equal to. So let's go ahead and fill in the rest of it based on the other one. Let's check our answer. Fantastic. All right, if anyone has any questions about how to set that up, remember, you just have to know which keywords to look for in your problem. So again, this one was differs. Find the test statistic for this hypothesis test. So we're looking for T naught. So let's go back to StatCrunch. I'm going to close out this box plot. We are now going to go to stat. We're going to go to t-stats because, again, we're looking at the mean. This case, we're not looking at paired data. This is independent samples. So it doesn't matter if the female from one is linked to the male of the other one. We're not talking about, like, do married couples or do brothers and sisters, anything like that. There's no connection here. This is independent. So we have the data. So we're doing two sample with data. So right here we see that the mean of the males is the first population. So we're going to put male here, female. Again, we're doing the hypothesis test. We've already got it all set up just how we need it. It needs to be equal to for the 0 for the first and does not equal. Remember, this is the same thing as saying mean 1 is equal to mean 2 if you were to add mean 2 to both sides. So this is the same thing as what we've got right here. So let's click compute. Here we have our t-stat is negative 9.6, yada, yada, yada. Here we are rounding to 2 places. So again, we have negative 0.96. Negative 0.96. Let's check our answer. All right, good job. Now, I do want to point out, it's important how you set that up. So make sure you have your population number 1 and population number 2 in line with the problem. All right, determine the p-value for this test. Well, lucky us, we already have it right there. As you can see in the corner of our window, it's 0.340. Let's check our answer. Excellent. All right, state the appropriate conclusion. Choose the correct answer below. So again, if our p-value is less than alpha, we reject the null hypothesis. Our p-value is larger than our alpha. So again, alpha was given as 0.01. So clearly it's the 0.3 is bigger than 0.01. So we already know that we do not reject our null hypothesis. So that tells us that we have either A or D. So let's go ahead and read. It says, there is not sufficient evidence at the level of significance to conclude that the mean income tax rate for males is different from the mean income tax rate for females. Or there is sufficient evidence at that level. Now, we know we're not rejecting the null hypothesis. We're not saying that the alternative is true, but we're saying we're saying that there is not enough evidence to support that alternative. So we're not saying that the null is true or the other one's true. We're just saying there is not sufficient evidence to support that alternative. So that would be letter A, answer A. Fantastic. And that's number 14. If you have any questions, let me know.